In this short video, let's practice finding the arc lengths. Find the arc lengths of the curve. Arc lengths problem. The curve is given as r of t equals 2 minus 3t, 5 cosine of 2t, and 5 sine of 2t, where t is from 0 to pi. Well, to start solving this problem, you need to remember the formula of the arc lengths we just learned recently. And the formula will look like L, or any way you want to notate it, integral from 0 to pi, in this case, from a to b, a huge square root, and then you start squaring the derivative of each component of the curve. So we will need to differentiate and then square. The first component, differentiate, and then prime. I'll put here prime, and then square the second component, and the same thing with the last one. Differentiate the third component, and then square it. And then solve this integral, hoping that it will be not too hard to solve it. dt. As you can see, dt at the end, t is from 0 to pi. So either you can do it separately, or you can do it right away. Sometimes it's not that difficult to actually differentiate everything right away. Derivative of 2 minus 3t is minus 3, and I'm squaring it. Plus, derivative of 5 cosine 2t will be minus 5 sine 2t, and then channel tells you times derivative of the function inside. That function is 2t, so derivative of 2t is 2. Squaring it, plus derivative of 5 sine of 2t will be 5 cosine of 2t, and the same way, channel tells me times 2. Squaring it. This integral looks hard, but actually, if we simplify it, it will be not that bad. Let's see. Minus 3 squared, all the negative signs actually do not really matter because we're squaring each component, each derivative, so it will be 9 plus 5 times 2 is 10, minus also goes away, so it's going to be 10 squared, don't forget about that, sine squared of 2t plus 5 times 2 is 10 squared cosine squared of 2t dt. Now I noticed that I can factor out 10 squared and 10 squared. Why do I want to do that? Every time you see sine squared and cosine squared with plus signs, you hope that they will be added together to get 1. That's exactly the idea here. I will factor out 10 squared, which is 100 by the way, and then I will have sine squared of 2t plus cosine squared of 2t dt. This is exactly what we want to get. Sine squared plus cosine squared is 1 when the input is the same for both sine and cosine. So the formula says sine theta squared plus cosine theta squared is 1. Theta here is 2t. So after all, we ended up with the integral from 0 to pi of the square root of 9 plus 100 dt. So it's going to be a square root of 109 times pi. Do you know how I got it so fast? Because since there is no variable, it's going to be t. T is going to be length of the interval from 0 to pi, and the length from the interval from 0 to pi is just pi. Or you can actually write it down slowly. T, a bar from 0 to pi, the square root of 109 times pi minus 0. So that is the final answer. Basically, your main job is to remember the formula, and the formula is differentiate each component first, square each derivative, add together inside of the huge square root, and integrate the square root from a to b, where a and b are limits of integration for t, and it gives you the arc length of the curve. Then carefully simplify everything, try to get into situation of sine square plus cosine square, simplify and get a nice final answer. Thank you for watching.